for the triangle congruence ASA and AAS lesson, what the ASA stands for is angle, side, angle, and this one is angle, angle, side. So on this one, different than SAS, when we did the SAS lesson last time, it was two sides and the angle between. This time, we're having two angles and a side. So the difference is, if I was talking about, let's do this first one, ASA. So I have my two angles. Now see how the S is in between the two A's? When you're proving something using ASA, the side has to go between the two angles. So in between these two angles is AB, and in between these two angles is DE. So what we would have to do is figure out a way to prove that segment AB was congruent to segment DE. So again, this is ASA. The side is in between the two angles. The second one, let's get some markings in there. Let's say that we know that angle N is congruent to angle Z and angle L is congruent to angle X. If we wanted to use AAS, the side would have to be just not the one that's in between. So there's two choices for this actually. We could go AAS, see how that side's not in between, so it'd be AAS, or, not looking at that, you could go this way, it could be AAS. So there's two different ways you can get AAS because there's two sides to choose from. On this one, you have to be the side that's in between the two angles, so there's only one choice for that one. Just as a reminder, when you're doing your triangle proofs, make sure you always list the given first. Whatever they give you, that comes up first in the proof. The second thing you should do is ask yourself whether or not you can pull a congruent statement from what they gave you. So sometimes they'll straight up say, like if I was using this example, angle N is congruent to angle Z, and that's given. Great. But then sometimes after that, they'll say like, D is the midpoint of AE. So if that's your given, remember what you should do to pull from that, let me get my paper from last time, is if they tell you that something is the midpoint, oh great, now I conclude that AC is congruent to DC, because that's what a midpoint is. Another hint that you can pull from a given statement is if they tell you whether or not the lines are parallel. So like on this one, if they say that you have BC is parallel to DA, you can use the corresponding angles or alternate interior angles to say that those angles are the same. So on this one, we have alternate interior, so I can say that they're the same based on that given statement. Then the next thing you should ask yourself, because remember you need 3 things are congruent, and usually the given will only give you 2. The third one you need to come up with on your own. Can you get a congruent statement based on how the triangles are drawn? So the first example, if you look at the way the triangles are drawn and you have overlapping sides like that, you should use the reflexive property because both those triangles share side AC there. The other one is vertical angles. So if I don't have an example of this, but if your triangles are drawn like so, just by the way that these are drawn, I know that this angle here has to be congruent to that angle there because they are vertical angles. And again, you only need 3 things. It has to be the correct 3 things, but only 3 for triangles to be congruent using SAS, ASA, or AAS.